Hello and welcome to the AI Research Roundup. I am Alex, and today is May 10th, 2025. We are looking at a research paper from Hugging Face's trending list, published just 5 days ago, titled RADLADS, Rapid Attention Distillation to Linear Attention Decoders at Scale. This paper introduces the RADLADS protocol. It is a rapid way to convert AI models called transformers, which often use softmax attention, a way to focus on important data, but it can be costly. RADLADS changes them to use linear attention, which is more efficient, especially for long inputs. This conversion uses knowledge distillation, where a new model learns from an existing one, and importantly, very few data pieces or tokens. Alright, so this first table really sets the stage. It compares RADLADS to several other methods. We see columns for tokens required, which are those data pieces we talked about, stages in the conversion, and then relative score. This score shows how well the converted model performs, often compared to the original, more complex model. The table lists scores for tests like Lambda and MMLU. These are standard ways to measure language understanding. Notice how RADLADS uses only 350 to 700 million tokens, much less than others, yet it achieves the highest relative scores on these key benchmarks. This really highlights its efficiency. Okay, so building on that efficiency, this figure lays out the actual conversion steps for RADLADS and a few other methods. You can see RADLADS uses a 4-step process. First, there is attention weights transfer, which means copying some initial settings from the original model. Then, attention hidden state alignment, where the new model learns to mimic key internal calculations of the original. Next is knowledge distillation, which we mentioned, where the new model learns from the old one's overall outputs. Finally, fine-tuning refines it further. This visual really shows the structured approach behind its speed. Following that structured process, this table then details the benchmark accuracy scores. These scores come from standardized tests, like Lambda and MMLU, which we touched on earlier, designed to measure how well these language models perform. The table compares various student recurrent neural network models. These are the new efficient models, some created using RADLADS, against their transformer teacher models, which are the original, more complex models they learned from. You can see for RADLADS converted models, like the QRWKV6-72B instruct, the scores are impressively close to their teacher. This really underscores that RADLADS not only converts models quickly, but also maintains very high performance. Alright, so this table now gives us a more granular look at specific benchmark scores. We are looking at performance on tests like Lambda, MMLU, ARC, which really tests reasoning ability, HelloSwag, PIQA, and Wino Grande. These all evaluate different aspects of language understanding and generation. You can see in the section our RADLADS models. Models like the QRWKV6-7B instruct and its variations often achieve the highest scores, indicated by the bold numbers. This detailed breakdown strongly supports the idea that the RADLADS conversion maintains excellent model quality across diverse and challenging tasks. To bring our discussion on RADLADS to a close, it is really clear this approach is a game changer for creating efficient AI. The big takeaways are its remarkable efficiency, converting huge models with very little data and cost into linear attention models. These models cleverly avoid the key value cache, or KV cache, which is a memory bank that can slow down traditional transformers. And importantly, these new recurrent architectures, models designed to process sequences by remembering prior inputs, still achieve excellent performance. That is our roundup for today. Thank you for joining me, Alex.